Hello, I am Vinita Navalkar and I am going to talk about dwarf planets today. So, we all know we have 8 major planets and then we also have a subcategory called dwarf planets, and apart from that we have asteroids, we have comets, all these are part of our solar system. Also we have different satellites, many planets have different satellites. Okay, we have just one, Earth has just one, that is our moon. But outer planets have many satellites. So, what exactly is this dwarf planet category? Okay. We know about belts, asteroid belt between Mars and Jupiter. Lot of rocky objects revolve around the sun. It's considered to be kind of a failed planet. It was supposed to form into a planet. However, due to gravity of Jupiter nearby, it eventually remained as chunk of rocks and a planet was not formed. But out of these asteroid belts, we have one largest asteroid, or now known as dwarf planet, that is Ceres. Okay, so between 1801 to 1851, Ceres and all these bodies were considered to be planets. Okay, but eventually, as more and more objects were discovered, it became too much to number or name everything as planets. Course, and then eventually they were called minor planets. Okay, but this is between Mars and Jupiter. Eventually around in 1930 we found first object beyond Neptune orbit, that was Pluto. That was called the 9th planet for almost 50 years or more than 50 years. But similar story happened there and we started finding more and more planets post Neptune orbit. They were also called trans-Neptunian objects. And then it was eventually in 2006 it was decided that it's not a good idea to call all these objects as planets, because we also found another object called Eris, which is almost the same size of Pluto but more massive than Pluto and quite farther away, almost at the edge of our solar system. So instead of calling that as a 10th planet, it was decided IAU General Assembly meeting in 2006 that we will have another category called dwarf planets, where all these objects which are similar to planet but not really planets are considered. So currently we have 5 main dwarf planets, but now the question arose is, how do you exactly categorize? What is a planet by definition and what is a dwarf planet by definition? So IAU came up with these 3 conditions for being a planet. One, it should orbit a host star. Obviously all the 8 planets that we know are orbiting our sun. Okay. In our solar system it's sun, in other solar systems you can consider whatever the host star is. They should be mostly round, and that is true for all 8 planets as well. Okay. Also this criteria was really important. They should be big enough, they should have enough gravity that they should have cleared everything around in its orbit. Okay, now what do I mean by everything around it in its orbit? If you consider the asteroid belt, Ceres is the largest asteroid in the asteroid belt. However, it has got lot of rocky asteroids close to it. Okay, so Ceres has ideally not cleared the orbit around it. Okay, there are lots of rocky objects revolving around sun in a similar orbit. Okay, same thing happens around Pluto. So when Pluto was discovered, that was the first Kuiper Belt object that was discovered. Kuiper Belt is another asteroid belt beyond Neptune. So Pluto was supposed to be the first Kuiper Belt object that was discovered, but eventually with more and more asteroids being discovered in Kuiper Belt, so as more and more asteroids were discovered around Pluto as well, it was very clear that even Pluto has not cleared its orbit. That is why this criteria for definition of planet turns out to be the most important, because this actually distinguishes a planet from a dwarf planet. So this subcategory of dwarf planet was considered, which definitely orbits the sun. They are nearly round, most of these planets are nearly round. Okay, dwarf planets are nearly round, but they have not been able to clear its orbit. So currently, as per IAU definition, we have 5 dwarf planets, which is Ceres. It's the only dwarf planet in our inner solar system between Mars and Jupiter. Other 4 are from the Kuiper Belt, that is Pluto, Haumea, Makemake and Eris. Okay. So currently this is the list. In near future it's quite possible that the list goes on increasing to a very high number. So this particular image will help you understand what I mean by clearing the orbit. So if you see this particular region, this is the inner solar system up to Martian orbit. Then we have this asteroid belt between Mars and Jupiter, and beyond that if you see near the Kuiper Belt object, can see this Pluto orbit, Makemake orbit, Haumea orbit, and Eris is quite farther away. It is the farthest dwarf planet that we have. So all these region, if you see, there are a lot of chunks of rocky particles here. Okay, so all these dwarf planets have not been able to clear its orbit the way the inner solar system or orbit up to Neptune is cleared. This is what it means by not clearing the orbit. If I just show you the orbits of all these dwarf planets and some of the Kuiper Belt objects, then you can see this blue orbit is Neptune. You have this is the Jupiter orbit, this is the Saturn orbit, Uranus, and the Neptune. Post that, all the orbits are very cluttered. Okay, so this particular image might be much easier to understand what I mean by orbits not being cleared. So let's come to each of these dwarf planets. Let's try to know more about each of these dwarf planets. So Ceres, the first one, as I said, between Mars and Jupiter, the asteroid belt between Mars and Jupiter. So it's one of the largest object in this asteroid belt, and it almost comprises of 25% of the total mass of the entire asteroid belt. Okay, so and its size is almost 1/13 the size of the Earth, with radius being only 476 kilometer. It is 2.8 AU away from the Sun. So if you just to give you an idea, so Mars is roughly 1.5 AU, Jupiter is 5.2 AU. So it is almost midway between Mars and Jupiter. Okay, and it takes around 4.6 Earth years to complete one revolution around Sun. Since Ceres is one of the closest dwarf planet to us, a mission named Dawn was undertaken, and this particular spacecraft orbited Ceres for some time, and we got quite good images and information regarding Ceres. This one image is of the crater, Occator crater, where inside you can see quite good albedos, and this is the base of that particular crater. It's been taken from almost an altitude of 1849 kilometers. There are a few other features that were seen on Ceres. Okay, so and most interesting observation or the discovery that has been is finding water ice. So these are all the places where these water ice was actually formed. The structures, as you can see, these are all water ice structures that were found on. Coming to the next dwarf planet, and the most famous one of course is Pluto, which actually led to the formation of this new category, that is dwarf planet. It was discovered in 1930 by Clyde Tombaugh, and in fact the name Pluto was given by a 11-year-old child from UK. It was coined by that child. So for a very long time, in fact, this was considered to be our 9th planet and considered to have the highest eccentric orbit in our solar system at that point of time, ranging from 30 AU to 49 AU from the Sun. Light from the Sun roughly takes 5.5 hours to reach Pluto. So if you compare it with Earth, it takes 8 minutes to reach Earth, but it takes 5.5 hours to reach Pluto. So that far it is, around at 40 AU. Initially Pluto was found alone, and then eventually Charon was discovered, and now we know that there are not just one but 5 moons to Pluto. So Charon is the largest moon of Pluto, almost half the size of Pluto, and so its center of mass is actually for the Pluto-Charon system doesn't actually lie in Pluto, whereas it lies somewhere outside Pluto. Okay. Initially means for a very long time. The only images that we got of Pluto are from Hubble Space Telescope, taken between 2002 and 2003, and all we can see is there are some dark patches, there are some very bright patches, and some tinge of yellow shades. Okay, so all that could have been deduced from here was it has got a trace of carbon monoxide and it has got a trace of nitrogen. That's all was deduced here. But to find more information about Kuiper Belt objects, NASA launched another spacecraft known as New Horizons. It almost traveled to the entire solar system starting from Earth. It started in 2006, it was launched in 2006, it traveled up to Pluto in 2016, and eventually in 2016 we got some clear images of Pluto and Charon as a system. Now this particular mission is actually traveling through a lot of Kuiper Belt objects and trying to understand the entire geology and entire structure of Kuiper Belt objects. So we got some interesting information from New Horizons mission. So the most important information that we got is that Pluto varies from being nitrogen rich to methane rich to water rich. So if you see this was the closest image of Pluto that we got from New Horizons, and particularly this heart-shaped nitrogen plane became very much very famous when the photos were released for the first time. So this particular plane is a nitrogen-rich plane. The rest of the structure is slightly mountainous, it is slightly cratered. Pluto also shows a lot of volcanic activities. Okay, so these are all interesting features that we have seen. So this, coming to this particular region, it is called Sputnik Planitia. It has got a thickness of almost 4 kilometers. Okay, this nitrogen rich structure has got a thickness of almost 4 kilometers, and because of this, in fact, Pluto has, it seems, it has been estimated that Pluto has reoriented itself, that is, its axis of rotation has reoriented itself. This particular side being heaviest has reoriented itself opposite to the Charon side. Okay, this is because constantly Charon has tidal effects on it, and this particular heavy mass, which is not distributed equally, has led Pluto to reorient its axis. So now this is almost diametrically opposite to where Charon. We have another very interesting feature which is now we know is common on Kuiper Belt objects, that is cryovolcanic activity. Now what do you mean by cryovolcanic activity? So generally we have volcanic activities here on terrestrial planets where we have hot magma flowing out. In cryovolcanic activity, it is generally the subsurface water ice that expands while cooling and that cracks the upper surface. Okay, and then you have some kind of material flowing out, that is cryovolcanic activity. So this particular activities are seen on Pluto as well as Charon both, and this is the region. You can see the zoomed in vision of this particular region just below this nitrogen rich plane. Here you can see these cracks developed because of the crust has been cracked because of the cryovolcanic activities. Okay, this was also taken by New Horizons spacecraft. Also we have within that heart-shaped structure, this is a close-up view of that heart-shaped structure, we have small tips of icebergs coming out from the bottom. So this clearly shows that there might be subsurface ice sheets which are kind of breaking the structure and penetrating from bottom. So this kind of structures have been observed on this particular surface. And also there is one interesting phenomena that is observed as these nitrogen rich cells, which are almost formed like cells, keep flipping. So there are strong convection currents subsurface which keeps turning this nitrogen ice cells. Okay, so all these things have been observed only because it's just one flyby mission, that is New Horizons. Few estimates have been done about the age of Pluto and Charon. So there is one criteria to define the age of a planet or age of any celestial body, considering how many craters it has. Okay, so if a body is volcanically dead, not really active, or does not have lots of atmosphere, then generally due to meteorite impacts, the body will have lot of craters. Contrastingly, if suppose there are a lot of tectonic activities going on and there is something that is flowing out on the surface, then you have these volcanic recoats happening. Okay, so even if you have meteorite craters, those craters are kind of recoated because of these volcanic activities, and that's how you consider that the surface is relatively new. Okay, so if you check if Pluto is studied, it revealed that its surface has been active for past 4 billion years, and relatively the surface is new, it is not that old. Whereas Charon has an ancient surface, there are a lot of craters seen on Charon, but also the equatorial plains of Charon also have some cryovolcanic activity. So those plains are relatively smoother as compared to the polar regions. Okay, as I have already discussed, so these flows are likely due to rupturing the crust due to expansion of ice below the surface. Coming to the third dwarf planet, that is Eris. So this in fact for some time was the farthest till 2018, this was the farthest object found in Trans-Neptunian list. But of course in 2018 few more objects were found which were beyond Eris. But Eris has been interesting because it is almost the same size of Pluto, but it is much more massive than Pluto. A very interesting phenomena that was also seen by observing Eris, and that was occultation of a very distant star by Eris. In fact, this is the farthest occultation that we have seen sitting here on the earth. So what is so important about seeing an occultation? So the interesting fact is that we were able to estimate what is the diameter of the Eris during this occultation, and that was estimated to be around 2326 plus or minus 12 kilometers, which is slightly smaller than 2372 diameter of Pluto, but otherwise they are nearly of the same size. But as I said, Eris is much more massive. So these are the only images that we have of Eris, and that too taken by Hubble Space Telescope. So Eris also has a moon, and this was the image, and this is the moon orbiting Eris. This is the estimated orbit of the moon, and its moon was named as Haumea. Okay, and this is the only clear image that we have got of Eris. It's one of the farthest dwarf planet. Maybe in future New Horizons will be able to share more information regarding Eris. So in fact, these are the series of images which helped us to detect Eris. So these are a series of 4 or 5 photographs taken, which shows that this particular point here, which is Eris, keeps moving in the background of distant stars. So orbit of the Eris is quite eccentric. Its eccentricity is 0.44. Its inclination is also too high. It is almost 44 degrees inclined to our ecliptic. So if you can see here, this is more or less the plane of our solar system, and Eris orbit is almost 45 degrees inclined to our ecliptic. In comparison with Pluto, you can see if this is the plane of our solar system, this is the inclination of Pluto, and this is the inclination of Eris. Okay, it's being highly eccentric. Its perihelion is just 37 AU. However, its aphelion position is 97 AU. So it's a highly eccentric orbit, and roughly takes 557 years to orbit Sun. And as I said, it is one of the farthest dwarf planets that we know as of now. However, if you see in this particular plot, you can see that its orbit is almost touching the Neptune orbit at one point, and for few years it is actually going to be closer to Sun than Pluto. So around in 800 years, Eris is going to be closer to Sun than Pluto. And in case of Neptune, its perihelion position is 37.9, whereas Neptunian orbit is roughly 37 AU. So it's not really going to interact with Neptune orbit, but it's going to come pretty close to Neptune orbit. Coming to the fourth planet, dwarf planet, that is Haumea. So it was again discovered by the same team of Mike Brown from Caltech, who discovered Eris. And in fact, this particular dwarf planet was claimed to be discovered by 2 different groups. One group was of Mike Brown from Caltech. Another group of Spanish astronomers also claimed to have discovered this particular dwarf planet. We don't have much data about this dwarf planet because no mission has been taken to Haumea. But from whatever estimates we have from the light curves that we have got from Haumea, captured by Hubble Space Telescope, we know that it must be an oval shaped, ellipsoidal shaped dwarf planet which has a semi-major axis almost twice that its semi-minor axis. Okay, so it must be ellipsoidal. So far we have discovered 2 of its moons, Namaka and Hiyaka. And also there is one interesting fact that we have observed about Haumea, that it has got the fastest rotation speed in our entire solar system. So it almost rotates in 4 Earth hours, okay, and that's the fastest. So another interesting fact we have observed from the light curves that we have got from Haumea, that it has got the fastest rotation speed in our solar system. It rotates about its axis in just 4 Earth hours. Okay, so the fastest known prior to this was of course Ceres, the dwarf planet, which takes 9 hours. Jupiter, if we compare, then it takes 10 hours, but so far Haumea is the fastest that we have discovered, that takes only 4 hours to rotate about itself. So this is the image taken again by Hubble Space Telescope of Haumea and its 2 satellites in 2015. Coming to the last dwarf planet, that is Makemake. This particular planet was also found by Mike Brown team from Caltech, and it is again slightly smaller than Pluto, but it is the second brightest planet that we have found in Kuiper Belt object after Pluto. It takes roughly about 305 Earth years to go around Sun, and it's roughly at a distance of average distance of 45.8 AU from the Sun. This is the only clear image of Makemake that we have from Hubble Space Telescope, and we have also found one moon. So far one moon has been discovered. Here in this glow of this Makemake, you can see there is a faint structure here, which is the moon that is orbiting this particular dwarf planet. Maybe missions in near future will be able to shed more light about these dwarf planets, and we might be able to find more dwarf planets as well.